Hi class, it's Mr. Trez, and this video is going to be about solving quadratic equations by graphing. Our learning objective: the student will be able to describe how to solve a quadratic equation by graphing. The student will also be able to identify the three types of solutions. The objective will be met if the student receives a 100% on their Google Slides assignment. Our essential question: how do you determine the solution or solutions of a graph that represent a quadratic equation? So let's just take a moment to review some of the key components of quadratic functions. First, we have our parent function, and the parent function is represented as f of x equals x squared. Our standard form is f of x equals ax squared plus bx plus c, where a is not equal to 0. The type of graph formed by a quadratic function is called a parabola. Our axis of symmetry is calculated by the equation x equals negative b over 2a. Our y-intercept is c, and that comes from our standard form of our equation. When a is greater than 0, so a is again represented by the a in our standard form. When a is greater than 0, the graph opens upward and has a minimum point. When a is less than 0, the graph opens downward and has a maximum point. Our x-intercept, these are the points where the graph crosses the x-axis. It's when y equals 0, and they are called zeros, roots, or solutions of a quadratic function. So now let's look at our key concept: solving quadratic equations by graphing. The solution or solutions of an equation can be identified by finding and identifying the x-intercept of the related graph. Solutions can have no solution, one solution, or two solutions. So the number one key is to find and identify the x-intercepts, because the x-intercepts are going to be our solutions. So if we take a look at our first example, this is an example that has no solutions. So as we can see, our parabola has no x-intercept. If it has no x-intercept, it has no solutions. Our next example has one solution. As we can see, our parabola has a solution right here. It has an x-intercept of 3. So our solution is going to be 3. And then finally, our next example, this parabola has two solutions. It has a solution at negative 2, an x-intercept, and it has a solution at positive 2, another x-intercept. So we would just write our solutions as negative 2 and positive 2. Let's just go through 3 more examples. So first we have our red function, and this is represented by an equation f of x equals 2x squared minus 3x plus 2. So this is represented by the red parabola on our graph. This graph has no x-intercepts, therefore the equation has no solution. So as we can see, there is no x-intercept for our red parabola, thus there were no solutions. Our blue function is represented by the equation f of x equals negative x squared plus 4x minus 4. The x-intercepts of the graph appear at 2, therefore there is only one solution, which is 2. So we take a look at our blue parabola. We can see it has an x-intercept at positive 2. That is our solution. And finally, let's take a look at our green function. Our green function is represented by the equation f of x equals x squared minus 2x minus 2. The x-intercepts of the graph appear at negative 1 and positive 2, so the solutions are negative 1 and positive 2. And as we can see, we have our green parabola right here. We have an x-intercept at negative 1 and an x-intercept at positive 2. And those would be our two solutions, -1 and +2. If you have any questions, please send me an email, and thank you for watching this video.